the moment energy became quantized. For centuries, energy felt smooth, continuous, and endlessly divisible, like water pouring from an infinite source with no smallest drop. It powered motion, heat, light, and life itself, always flowing, always blending, never jumping. Then a single moment revealed that energy did not flow at all. It arrived in steps. To understand why this moment changed physics forever, we must return to a time when energy was treated as an abstract bookkeeping tool rather than a physical substance with limits. Energy was something you calculated, not something you questioned. It explained why objects moved, why machines worked, and why heat spread, but it was never expected to have structure. It could be divided endlessly, reduced smoothly, and shared continuously without restriction. That assumption felt so natural that no one thought to challenge it. This view worked beautifully for classical mechanics. A swinging pendulum lost energy gradually. A rolling ball slowed continuously. A hot object cooled smoothly over time. Every process appeared to confirm that energy could change by any amount, at any scale, without resistance. The universe seemed infinitely flexible. But trouble appeared when scientists looked closely at heat and radiation. When objects glowed, the color and intensity of their light refused to match predictions. Classical theory demanded that energy be emitted across all frequencies without limit. Reality refused. Measurements showed sharp cutoffs. Energy did not smear itself smoothly. It arrived selectively. At first, this mismatch was treated as a technical annoyance, a problem of calculation, a flaw in measurement. No one suspected that the foundation itself was wrong. But as experiments improved, the discrepancy grew impossible to ignore. The equations predicted infinities. Nature delivered boundaries. The only way to save physics was to accept an unthinkable idea. Energy was not continuous. It came in discrete packets, fixed amounts, indivisible units that could not be subdivided further. Between them, nothing existed. This proposal felt desperate. Even its author treated it as a temporary fix, a mathematical trick to make the numbers work. But the universe did not treat it as a trick. It enforced quantization everywhere it could be tested. Atoms absorbed energy only in precise amounts. Light was emitted only at specific frequencies. Matter ignored all other possibilities completely. Energy behaved less like a fluid and more like currency. It could be exchanged only in exact denominations. This was the moment energy became real in a new way, not as a continuous quantity, but as a structured one. The universe revealed that it had resolution, that below a certain scale, change itself was forbidden. What began as an attempt to fix a glowing problem became the discovery of a fundamental limit. Energy was no longer just conserved. It was counted. And once energy had structure, nothing built on it could remain the same. Once energy was revealed to be quantized, the consequences spread far beyond glowing objects and laboratory measurements, reaching into the deepest assumptions about how change itself could occur. If energy could only be exchanged in fixed amounts, then motion, interaction, and even stability were no longer smooth processes. They were negotiated through discrete steps enforced by reality itself. Atoms became the clearest evidence. Electrons did not slowly drift closer or farther from a nucleus. They occupied exact energy levels, like rungs on a ladder that could not be stood between. An electron could absorb energy and jump upward. It could release energy and fall downward, but it could never exist in the space between. Nature allowed states. It forbade transitions. This explained mysteries that had lingered for decades. Why atoms emitted sharp spectral lines instead of continuous rainbows. Why elements had distinct chemical identities. Why matter was stable at all. Without quantization, electrons would spiral inward endlessly. Atoms would collapse. Chemistry would never exist. Quantized energy acted like scaffolding. It locked matter into repeatable patterns. It created reliability in a universe that otherwise favored collapse. Stability emerged not from smooth balance, but from restriction. The universe survived because it said no to most possibilities. This restriction reshaped motion itself. Particles could not shed energy gradually. They released it suddenly. Transitions were abrupt. Processes that looked smooth at large scales were revealed to be composed of countless microscopic jumps, each one obeying strict rules. Even light, once thought to be the ultimate wave, now followed this structure. Brightness increased not by strengthening photons, but by adding more of them. Energy was counted. Interaction became arithmetic. This transformed energy from a passive quantity into an active rule. Energy was no longer just something systems had. It was something systems obeyed. It dictated what could happen, when it could happen, and what was forbidden entirely. The universe stopped being infinitely adjustable. It became precise. Resolution appeared everywhere. Change itself was quantized, and with that precision came a deeper question. If energy moved only in steps, then time, motion, and causality might also be built from indivisible units. Reality was no longer continuous underneath. It was granular. Physics had crossed another boundary. The smooth universe was gone. In its place stood a world built from jumps, where stability, identity, and structure existed only because change was limited. And the deeper scientists looked, the more they realized that quantization was not an exception. It was the rule. This is where quantization stopped being a helpful explanation and became an unavoidable conflict. Because once energy was limited to fixed packets, the classical picture cause and effect began to fracture in subtle but deeply troubling ways. If systems could only change by jumping between allowed states, then the smooth unfolding of reality was an illusion created by scale, not a fundamental truth. The universe was no longer gliding forward. It was stepping. This created a tension physics could not ignore. Classical laws relied on continuity to predict motion precisely. If you knew a system's current state, you could calculate its future exactly. But quantized energy destroyed that certainty. Between allowed states, nothing existed to track. No intermediate values. No continuous path. Only outcomes. Particles did not move smoothly from one configuration to another. They waited, then they jumped. The timing of those jumps could not be predicted exactly. Only the probability could be known. Reality introduced chance at its core, not as ignorance, but as structure. This randomness was not optional. It could not be eliminated with better instruments. The smallest energy packet defined a limit beneath which prediction failed. No measurement could bypass it. No refinement could smooth it out. The universe enforced uncertainty by design. As more systems were examined, the pattern repeated relentlessly. Vibrations in solids occurred in quantized modes. Magnetic moments snapped between allowed values. Even angular momentum came in fixed steps. Nothing escaped the rule. Discreteness was everywhere. This forced physics to confront an uncomfortable truth. The laws governing large objects were approximations. They worked only because countless quantum jumps averaged together. At small scales, determinism collapsed. The universe did not calculate the future. It sampled it. This sampling created stability and chaos simultaneously. Atoms were stable because forbidden states prevented collapse. Yet outcomes were uncertain because transitions were probabilistic. Reality balanced order and unpredictability with exquisite precision. Too much freedom would dissolve structure. Too much rigidity would freeze change. Quantization allowed both. The deeper scientists looked, the clearer it became. Energy was not just quantized to solve specific problems. It was quantized because the universe required limits to function at all. Without minimum steps, systems would bleed energy continuously. Nothing would hold shape. Everything would decay instantly. This reframed quantization as necessity, not curiosity. It was not a strange rule added onto physics. It was a scaffolding holding reality upright. Every interaction was constrained. Every process was negotiated through allowed exchanges. Change itself was rationed, and as this understanding matured, the conflict sharpened further. If energy was quantized, then information was quantized. If information was quantized, then knowledge itself had limits. The universe was not just granular in matter and motion. It was granular in what could be known. Physics had not merely lost continuity. It had lost certainty. And standing at that edge, it was forced to ask whether the universe had always been this way, or whether quantization was pointing toward an even deeper structure still waiting to be uncovered. The climax of the story is not the discovery itself, but the realization of what quantization truly means for reality as a whole. because once energy became counted rather than continuous, the universe quietly revealed that it operates with limits built into its very foundation. Change is no longer free. It is rationed. Every interaction must pay a minimum price. Every transition must occur in allowed steps. Reality does not glide. It advances in controlled increments. This explains why the universe is stable at all. Atoms persist because most energy exchanges are forbidden. Matter holds shape because collapse paths are blocked. Structure survives because not everything is allowed to happen. Quantization acts as a gatekeeper, preventing chaos while still permitting transformation. The universe is not flexible. It is selective. What once felt like a restriction became a source of richness. Because energy is quantized, chemistry exists. Because chemistry exists, biology emerges. Because biological systems can store and exchange energy discretely, life becomes possible. Every layer of complexity rests on these smallest steps being enforced without exception. This reframes how progress works. Nothing in the universe happens continuously at the deepest level. Motion appears smooth only because jumps are unimaginably small and unimaginably frequent. Beneath every flowing process lies a ledger of exchanges being counted one by one. The universe keeps perfect accounts. Quantization also sets absolute limits. There is a smallest action, a minimum disturbance, a fundamental resolution beneath which questions lose meaning. You cannot divide energy endlessly. You cannot extract information without cost. You cannot bypass the structure that reality enforces. Limits are not failures of knowledge. They are features of existence. Once energy was understood this way, physics never returned to comfort. The smooth universe vanished permanently. In its place stood a reality built from permission and prohibition, from allowed states and forbidden gaps, from discrete exchanges stitched together into experience. The moment energy became quantized was the moment physics stopped pretending the universe was infinitely adjustable. It was not. It was precise, measured, counted, and once you see that, you begin to understand why reality holds together at all. The moment